thank you for inviting me today. Great to have so many people here, both from Norway and from Singapore. I think it's exciting to hear all the speakers today. And I think what I'm going to talk a little bit about today is what we can do now, what we can actually act on. There's an awful lot of discussion about plans. We too, as a company, there's a lot of 2030, 2050, future technologies availability. And I think what's exciting too is what we can do today with what is available. What we can do to make a difference, what we can do to decarbonize immediately, and what we can do to scale that as much as possible to have a real impact. And I think that's what we at Yinsen really want to do and see how quickly we can do it. Today I was meant to be partnering a Norwegian company here, Lift Ocean, who we've invested in, who design hydrofoils, because hydrofoil is an incredibly exciting technology for reducing drag, increasing the efficiency of electric vessels. Unfortunately, they couldn't be here, but I've got a little video from what they're doing, because I could hear everyone loves a few little videos here, you see. So you can see. Will it start when I press?
As a sailor, that we have the mentality that we have to do everything to make the boat go just a little bit faster, a little bit better, a little bit smoother through the waves, and get a better experience.
I'm an aerospace engineer. I always look for designing the most efficient object.
So that mentality I want to bring into powerboating.
When I talk to my kids, I usually say that I make boats fly.
So hydrofoils has been around for more than 100 years, but they were not cheap enough, they were not efficient enough, and they didn't have a control system and software and so on. But then something happened in the sailing industry in the America's Cup, and foiling stable, and they were going fast. So sailing has shown us the potential of hydrofoils.
When boating traditionally, you have a lot of friction in the water, so getting the boat out of water reduces friction dramatically.
Our goal is to bring the experience of the America's Cup, the experience of the racing boat to the industry.
So the boat builders, they can make hydrofoils themselves, but they don't have the competence, they don't have necessarily the funding, or software, and people to get their boats in hydrofoil. And that's where Lift Ocean comes in.
You can imagine kind of like Lego, that we provide a kit that all the boat manufacturers can easily integrate into their boats.
And this is regardless of what propulsion technology we use. We will do what we are good at, getting the boats to fly.
We really can change and revolutionize the industry.
By providing a relatively cheap and safe and reliable hydrofoil system to the boat manufacturer.
The boating industry now is standing in a situation where something needs to be done.
We need to think differently in order to make the green transformation on water.
The key to electric vessels is getting the greatest range. So it's about reducing the drag. I've looked at a lot of technologies. I've worked with a lot of companies looking at what is the best alternative. And as of today, I haven't seen anything that's better than the hydrofoil.
But the complexity of making an hydrofoil super efficient takes experience and great software, which we have.
The challenging stuff are always the most interesting.
It's amazing and it's so fun. It's almost like I would have paid to be working here. Don't tell my boss I said that.
So in this project, we have our main partner is Yinsen Green Technologies. They have a vision to revolutionize the harbor transportation, going from old vessels consuming a lot of diesel, oil, to zero-emission hydrofoil hovercraft.
This will be mounted to the hydroglider in the harbor in Singapore in not too distant future.
I think what Lift Ocean is doing at the moment together with Yinsen is just a start. It gives the first vessels in operation. Then building on that, the sky's the limit.
It's all about efficiency on a sailing boat. We want to bring that into powerboating. That's our DNA, efficiency.
A lot's already been said in the video. I add a little bit more. Why did we even start working with Lift Ocean? Why were we looking at hydrofoils? It started with the fact that I've been living in Singapore for a long time. And I've been looking at the harbor craft in the harbor here. And I've been looking at those harbor craft plowing through the water. And some of them look as if they were designed to displace as much water as possible rather than cut through it. There are some of them a little bit better, but I thought we can do this much better. We can start again. And when we're going to use batteries, when we're going to use efficient vessels, we have to get that efficiency picture right. Otherwise, we'll never make the range effective with a battery electric solution. And it's all about not only about the energy efficiency, but also the noise, the minimal wake, the minimal disturbance to the other vessels in the harbor. And to do all of that, we've done detailed analysis. We've done simulations. You saw the team there, the Italians on the team. These are the guys designing the America's Cup racing boats for Team America. So these are some of the best guys in the world at designing hydrofoils. And we're working with them to design the best boats to have here in Singapore. And I think that's incredibly exciting. The hydrofoil design for our vessels, there's a main foil that lifts the boat, and there's a rear foil where we also have the propulsion. And there's a flight controller which regulates this basically like an aeroplane. And that's the big difference between modern hydrofoils and older hydrofoils. In the old days, the hydrofoils literally bumped along the water, were lifted up by their speed. But today we have a different situation. Today we're continuously controlling the main foil to fly evenly at an even height above the waves and to give a fantastic smooth ride to the crew that's riding on board this vessel. What you can see here is the energy efficiency. This is what it's all about. Once we get the vessel speed up, the power does not increase for a hydrofoil. You see you have the liftoff speed there, perhaps at 12 to 15 knots. And you see on a traditional vessel, you have an exponential rise in the energy which is required to operate at faster speed. Whereas for the hydrofoil, that stabilizes, and we hardly use any more energy to go at the higher speeds. So here we can operate at 20, 25 knots in the port of Singapore at a very low energy consumption. So there's a lot of technical innovations we're putting into these vessels. We're putting a smart bridge, we're having active foiling control, we're looking at auto docking. We're preparing these to be autonomous ready, remote control ready right from the beginning. We're a little bit like ABB were presenting earlier. We are having collision avoidance integrated. We're having smart technology digitally involved in all of these vessels from day one. And of course, they're going to be energy efficient. So we're designing them in the lightest possible materials, and we're designing them to have every possible advantage over the existing hovercraft. We're also using 3D printed materials, and it was one that was mentioned earlier here. We've also been in the program together with Wilhelmsen as well, and the support of everyone here in 3D printing spare parts for our FPSOs as well. So we're very much into the 3D printing, utilizing the new technologies to optimize all of the products that we're working with. I think the product philosophy here is that Lift Ocean can deliver the hydrofoil technology, and they can deliver it as a kit. They can work with any different vessel manufacturer. So anyone who's interested, it's an opportunity. So that they can be vessel builder anonymous and provide what is required, both from a technological and hardware standpoint, to make a vessel fly. In Yinson Green Technologies, we're working across the marine segment. We're not just working with electric vessels. We're working with the digital interface. We're working with the decision support and monitoring, the autonomous vessel tech. And we're also looking at a solution for battery swapping to allow continuous operations. Just recently as well, we invested in GotSurge, a Singaporean company who's also looking at the operational platform for operations. So this is the Hydroglider. Power reduction of up to 50 to 80%, up to 90% reduction in the cost of energy. And it's important to remember there that electric boats are inherently more efficient than the diesel boats, even if the grid at the moment is LNG. So remember, these are efficient vessels regardless of that initial power source. And I think it was good, as everyone's mentioned today, we're not losing the 80% of energy going through a hydrogen fuel cell or ammonia. We're probably losing 4 to 5% of the energy, the renewable energy that we want to get into these vessels in the future. We're going for a totally new Tesla look. We're working with Boning for an integrated, fully automated bridge. We are going with the swappable batteries from our partner Shift, who are also working on a number of projects here in the port of Singapore. So we're going to be implementing swappable batteries in our vessels coming to Singapore next year. We're looking for lightweight composite materials. We're doing 3D printed seats. We're doing rooftop solar panels to recover as much energy as we can also while we're in operating, and particularly when we're we're standing by next to a tanker, next to a container vessel, wherever we are taking people in or out in the port. We've designed an E-pod propulsion system on the rear foil together with Engtech here in Singapore, being fantastic partners, developing a totally new solution specifically for these vessels and for the operation here. So overall, what's the impact? It's a zero-emission crew transfer vessel. It's efficient because of the lower drag from the hydrofoil. It has minimal wake, very little noise, and it gives a smooth ride above the waves. There are 100 vessels or more, crew transfer vessels in Singapore today, and we think we can replace all of those with modern, efficient vessels. This is just a couple of pictures from the actual construction going on at the moment, because we're building these. I think that's what's exciting too. We're doing it now. We're not talking about what we can do in the future. We're building today. We're also doing another vessel in collaboration with the MPA, with SMI, which is being supported with $3 million together with our Singaporean partners here. We're building it at Lita Ocean. We're working with CTEC for the naval design. And all of these partners are pulling together to get this into the water, Rena on the class side here, to come into operation as soon as possible. Again, a lot of the components for our fast crew vessel and for our cargo vessel are standardized. Same propulsion line, same batteries, same main components, same control panels. So we're trying to standardize and bring a high-tech solution into operation as soon as possible. That's the Hydromover cargo vessel there again. You can see the partners. Also working with TCOMS, SIT, Jurong Port, to bring that forward. So another very exciting project here for Singapore. I think that was it. Thank you very much. Thank you to everybody.